now that we have supplementary angles, we can use the fact that this is equal to 5x from over here, and this is equal to 4x. But before we can use it, we got to write it in the given. So the measurement of angle ABC is equal to 5x, and the measurement of angle CBD is equal to 4x. Now we're going to use it. We're going to substitute that value. So that's 5x plus 4x is equal to 180. And that was substitution. From here, we're going to combine like terms. Remember, that is an action, not a property. So this can be written as 9x because it's the same thing. So we're replacing it. Means substitution. Now we're going to divide by 9. X is equal to 20. So we divided by 9 to both sides. Dividing by 9 to both sides is division, property of equality. And you divided to both sides to keep them equal. Number 3. For number 3, there we are given that angle 1 is congruent to angle 3. So they tell us that this angle is given that is equal to that angle, given. We can also say that angle 1 and angle 2 are vertical angles. So I'm going to highlight them. They look like they're crossing lines opposite to one another, and that's how we can identify that they're vertical angles. And this would be by the definition of vertical angles. So if we can say that 1 and 2 are vertical angles, we can also say that angle 3 and angle 4 are vertical angles. Now that we know that they're vertical angles, we can say that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And this is by the vertical angles theorem. So let's take a look at that vertical angles theorem. The vertical angles theorem, it says that if they're vertical, then they're congruent. I'm going to write this next step down just so we can understand why we're writing that angle 2 is congruent to angle 3. Well, let me rewrite this one. I can rewrite this one. Angle 2 is congruent to angle 1 by the symmetric property. I can switch the order. And then up here, I had that angle 1 is congruent to angle 3. So that was given. That means that I really didn't need that information, and I can write that the angle 2 is congruent to angle 3 by the transitive property. So I'm going to do it again. Now I'm going to write that angle 2 is congruent to angle 4. How did I get that? Well, I have that angle 2 is congruent to angle 3, and I have that angle 3 is congruent to angle 4. So I use the transitive property again. Number 4. So number 4 says that DBE and EBC are a right angle. It also says that angle ABD and BDBE are complementary. So these two over here are complementary. What do we usually start with? The given. So angle DBE and angle EBC form a right angle. And we also know that the angle ABD and angle DBE are complementary. And that was given. Then angle DBE and angle EBC are also complementary. So that was these two. We knew that they were right, so we could say that they're complementary. And that's the complement theorem. So let's take a look at the complement theorem. And the complement theorem is, if you know that they're right angles, then you know that they're complementary. So if you know that they're right angles, you know that they're 90. Okay? So now we can say that angle ABD is congruent to angle EBC. And this is by the congruent complement theorem, which says that if you know that this is a right angle and this is a right angle and they share an angle, then these two have to be congruent. Five. For number 5, it says that BAD, that's this angle right here, is congruent to the angle EAC. That's this one over here. What we're trying to show is that BAC, the little one over here, is going to be congruent to this little one over here, EAD. So what we start with is the given. Angle BAD is congruent to the angle EAC. Given. Because they're congruent, we can also say that their measures, the measure of angle BAD is equal to the measurement of the angle EAC. So changing from congruent to equals, the congruence theorem. Now we're going to use the angle addition postulate. And what that says is that when you add two pieces together, they give you a whole. So we're going to write that the measurement of angle BAD is equal to the measurement of the angle BAC plus the measurement of the angle CAD. We can also write that the measurement of angle EAC is equal to the measurement of the angle EAD plus the measurement of angle CAD. So that's the two little parts equal the whole. By substitution, I can replace this with all of this in this equation. So it looks like the measurement of angle BAC plus the measurement of angle CAD is equal to, and instead of writing this, I can write all of this for this equation. The measurement of angle BAC, oh, sorry, I miswrote it. It's this one over here. EAD plus the measurement of angle CAD. And now what I'm going to do is subtract the measurement of angle CAD from both sides. I'm going to subtract it over here, the measurement of angle CAD. So I subtracted on both sides. So this would be the subtraction property of equality. It tells me that now I have the measurement of angle BAC is equal to the measurement of the angle EAD. From an equal sign to a congruency sign. The measurement of angle. So instead of an equal sign, we have a congruency of angle BAC, and the angle EAD is by the congruence there. Woo! Last one. For number 6, it says that this is a bisector. Bisector is the means cut in half in equal portions. So we're going to start with the given. How we write array is that we start from the end point and go to the right every time in notation. But for writing it, we start with the end point B, and it says it goes towards the direction C. So even if we had this array right here, we would still make the notation like this and put B as the endpoint and towards the direction F. So it would still look like this even though it looks like it's going the opposite direction. Bisects angle ABD, and that was given. Because it bisects, we can say that the angle CBD is congruent to the angle ABC. And that's by definition of angle bisector. We can also say that angle ABC and angle FBE are vertical angles. And that's by definition of vertical angles. So I'm going to make the notation ABC, so this one right here, and FBE, this one right here, are both vertical angles. Because they're vertical angles, now we can say that the angle ABC is congruent to the angle FBE. And that's by the vertical angles theorem. Once we know they're vertical angles, then we can say that they're congruent. I'm gonna write this one right here because it's from this up here. So I also had that angle CBD is congruent to angle ABC. So look at this part. This part repeats. That means that I can write that the angle CBD is congruent to the angle FBE. And that's by the transitive property. Once that we have that it's congruent, we can also say that it's equal. So the measurement of angle CBD is equal to the measurement of the angle FBE. And that's by the congruence there. Okay, so you know that you're able to use this on the notes. If you need to, please rewind and push pause to fill in all your proofs.